Hello and welcome. And right now we are looking at the hydrocarbons. So this will be the first section of this will be the first homologous series that we will deal with, the alkanes, alkenes, and alkynes. And before I move on to that, I want to remind you what a homologous series is, right? The homologous series is the group of compounds that contain the same functional group. So for example, any molecule that has got only single bonds between its carbon atoms with only hydrogen and carbon in it, we call those alkanes belonging to that homologous series. And then when we spoke about functional group, we also said what the meaning of a functional group is. A functional group is a group of atoms, or it can even be a single atom, or even a type of bond that gives a molecule its characteristic reaction attributes or traits. Sorry, let me just get my pen ready. That gives it specific attributes and molecules its traits over there. So what do we mean by that? We mean that at the end of the day, the functional group is the center of chemical activity. Anyway, so now we move on to the hydrocarbons. Now, what is the hydrocarbons? Well, the hydrocarbons is a group of molecules, right? Let me just see. The hydrocarbons, they are a group of molecules that contain only hydrogen and carbon. I'm actually just going to clear that because I've already written it there. They are a group of molecules that contain only hydrogen and only carbon. Okay, only hydrogen and carbon. And then similarly, we will be dealing with aliphatic compounds. Now the aliphatic compounds are compounds that contain chain structures, right, without benzene rings. So with the hydrocarbons, you can get these carbon molecules, carbon-hydrogen based molecules that contain cyclic structures or acyclic structures. Now, acyclic structures, these also fall into the category of aliphatic compounds. Okay, we need to work a little bit more on that handwriting. Let's just get the eraser there and get rid of that. Aliphatic compounds, and ones that contain benzene rings are called aromatic compounds. Now, the hydrocarbons, there are three categories of hydrocarbons. The first is the alkanes, the second is the alkenes, and the third is the alkynes. So this is where handwriting becomes very important, and in fact that says alkanes, this says alkenes, and this says alkynes. Now with your alkanes, if you look carefully over there, you can see there's an ANE. Over here we've got an ENE, and over there we've got YNE, right? Let's just spell that out again and look at how it ends. It ends in YNE, and here it ends in ENE, and over here it ends in ANE. Right, so how you write your A's and E's will become very important. So that's the hydrocarbons. They are compounds that contain only hydrogen and only carbon, and we will be dealing with straight chain structures instead of rings. And these structures, we will deal with the alkanes, the alkenes, and also the alkynes. Now, what is an alkane? It is a hydrocarbon that only has single bonds, right? So I'll just put in there only single bonds. It only has single bonds, right? Over here contains at least one double bond or contains double bonds, and over here something is considered an alkyne if it contains at least one triple bond. Okay, and of course if it has more of those more triple bonds, then it will be still be an alkyne. If it has more than one double bond, it will also be an alkene. Right, so let's go to the next page. Right, cleared that. Okay, so we've already in the previous slides mentioned what are saturated and unsaturated compounds, and I've given you certain examples. Saturated compounds are compounds that contain only single bonds between the carbon atoms, right? They only have single bonds, right? Like this one over here, that's a saturated hydrocarbon. And this one over here, it is unsaturated because there is a double bond. So anything that has a double bond or a triple bond is an unsaturated compound. I mean between its carbon atoms, right? Okay, on the next slide. Oops, buttons are not clicking. Now, one thing you need to do is set up a summary sheet, right? And I'm going to do this with you because I want you to do that. Now, I don't have a pen that works with Microsoft Word at the moment, so I cannot set up my summary sheet and write it and save it as a PDF. So I'm going to type it out, but I expect you to write it out, because as you write out these things, you engrave a neural pattern in your brain that makes memorizing the work a lot easier. Okay, so here's my OChem summary sheet. Let me just get out of this. There's my summary sheet, and we're going to talk about naming carbons according to a system called the IUPAC naming system. IUPAC system, right? So that's what we're going to look at. IUPAC names, or also called the systematic name. Right. Now, one key question to remember is, what does IUPAC stand for? And let's just get this out of the way there. What does IUPAC stand for? Well, IUPAC stands for the International Union of Pure and Applied Chemistry. I think we should make the font slightly smaller, just to give us good space that you guys can still see. Right. International Union for Pure and Applied Chemistry. Oops. Okay, so the International Union for Pure and Applied Chemistry. Now, here's a question for you. What does IUPAP stand for? Notice the key difference. The one is IUPAC and the other one is IUPAP. That's for you to think about. Okay, so on our naming summary and convention sheet, what we're going to do is we're going to do the following. We're going to start looking at how many carbons the molecule has. So I'm just going to put here, let's just put a line below this, right? Okay, so let's say when molecules have got one carbon atom, we will name the name meth, right? Its name will start with meth. When it has two carbon atoms, its name will start with eth or eth, right? When it has three carbon atoms, its name will start with prop. When it has four carbon atoms, it will start with but or but. When we have 5 carbon atoms, the name will start with pent. Now be sure to write this down. You need to have a book with a page in your book just for this. It's your naming summary sheet. 6 carbon atoms, that will be hex. 7 carbon atoms in its longest chain will be hept. And 8 carbon atoms will be oct. Now of course you can go to 9 and 10. It is non and dec. Let's just put it there. 9 carbon atoms is non, and 10 carbon atoms in the longest chain is dec. Now for the purposes of NSC examinations in South Africa, we only work with 8 carbons in the longest chain. So that's the first part. You need to commit this to memory. Meth, eth, prop, but, pent, hex, hept, oct, non, and dec. Now of course I was cheating because I was reading it off there, but if it's meth, eth, prop, but, pent, hex, hept, oct, non, and dec, you can go up until 8 carbon atoms. So that's the first thing I want you to add to your summary sheet, right? So as we go through this, we will start adding on names to the summary sheet, right? So let's get back to the presentation over there, and let's look at the, so we've already set up our OChem summary sheet, and now we can move on, right?